Hey Mustafa, Assalamu alaikum, how are you?
Welcome, salam, sir. Fine.
Good. Okay, so we were learning about the changes that occurs at puberty. Right now, what are the different changes that occurs in the adolescence?
Sir, I asked my teacher about if that
Hmm.
metals and non-metals is coming. It's not coming. Only the first chapters of uh, it.
Okay. Only the first chapters of each chapter is coming in
Yes,
your
sir.
upcoming exam. Okay. Will that be in the syllabus or not? That's what I actually asked you to ask from your teacher. I mean to say, will it be taught in the future or not?
Sir, I just asked him, will it be in the PA or no?
Oh, actually, you should have asked whether it's going to be in the
No,
like
no, no.
later on.
Sir. I
Uh-huh.
forgot. He's teaching it. He's teaching it right now.
He's teaching it. Okay,
Yeah,
okay.
yeah.
That's it's going on actually. Okay, no worries. So when extra class will be scheduled, I'll be calling you in that. Okay, now. Give me 1 minute. Let me open that.
Sir, I'll come back. I think my mouse's
Today.
battery.
Okay. Be back quickly. And today is Tuesday, no? Right. For you, where is was? Hold on. Force and pressure, synthetic fibers and plastics. 23rd June. Okay. Yes, are you back in the class? Yes, Mustafa.
Sorry, sir.
Yeah. Okay, no worries. Okay. Was what I'm thinking now. I took up this chapter Age of Adolescence since Pawan had this chapter in his upcoming exam. Okay. Right now, what I'm seeing that, as I already know that you have the chapter force and pressure and synthetic fibers and plastic is there. Okay, it's 10 minutes past and no one else has joined. So I think we can start the chapter synthetic fibers and plastics as of now. What do you say? It is going to be there. Anyways, maybe we'll have to schedule extra class for the chapter synthetic fibers and plastics if others don't happen to have this chapter in the syllabus. So I
Second,
think it would be better. Tell me.
second, ocean pressure.
Yeah, we can start that one as well, as you wish. Okay. Give me little time. Okay, now let me just clean this. Otherwise, that will create some issue in discussion. Okay, we are good to go. All right. So that is force and pressure. Okay. We are doing this for this class only. In the next class, we might not be able to do the same chapter. All right now. So force and pressure. Let us understand what basically force and pressure is. In very simple terms, we basically say that force is push or pull. The action of pushing or pulling something is called as force. That is the most simplest definition of force. Right now, it's a fundamental concept of physics that basically will be describing the interaction between the objects that causes them to change their motion or change their shape. Like by the application of shape, if an object is at rest, you can bring it in motion, or if an object is already in motion, you can bring it to rest, or you can decrease its speed, or you can increase its speed. Or by application of force, you can change the shape, you can change the direction of the moving object as well, isn't it? Further, if force comes in existence, comes into play between two objects, so there must be some interaction, you understand, no? They must either be in contact, must be in direct physical contact, or must be applying some force upon each other, must be interacting even if they are uh, some distance apart from each other. Getting it, Mustafa?
Yes, sir.
Right. So force, it's the most fundamental concept in physics. Right now, it tells us how interaction takes place between the objects, and that interaction causes them to change their shape, change their um, motion, change their direction, etc. So it can, when you apply force on an object, it can either cause it to move, either make it a stop, or change its direction, right? So force, in the most simple terms, we say that force is a push or pull applied on an object. A push or pull applied on an object is called as force, right? And it's a fundamental concept of physics. And it tells us about the interaction between the objects because of which they would be changing their position, changing their shape. Change takes place in the direction in which they are moving. So that is the thing. Getting it? So later on further, we will learn that this force can be of different types. Like here, we are seeing that this apple falls back towards the earth, right? So is there direct sorry, is this apple in direct physical contact with the earth, or is it at some distance apart from the earth? Hmm? Is it
So,
attached to the earth via a string, via a rope or something?
no, sir.
No.
A gravitational force.
Right now, so basically it's a gravitational force over here. And again, in the next example, you can see it's magnetic force. Even if the two magnets are some distance apart, they will be exerting a force of attraction or repulsion on one another. And the third one is, if you have already learned, tell me. The third one is example of, obviously, have you participated in this sport in the school? Does this kind of a sport happen? Tug of war?
Yes, yes, I have played tug of war.
Mm, okay. So that is muscular force. Now, basically, your muscles are applying force over here. Getting it? Okay. So we can classify it as contact force and non-contact forces, which we'll be learning later on in detail. Okay, now. Hey Fatima, Assalamu alaikum.
Walaikum Assalam, sir.
I'm upset with you. Where have you been? Hmm?
Uh, yes, sir.
Where have you been?
No, sir, I couldn't find the ID, so that's why I
Oh,
want to.
okay, so you have shifted to your place. You have shifted to the new
Yes,
location.
yes, yes.
Okay, okay, good. Okay. In the background, I can see some calligraphy. Did it yourself, or is it some ready-made, like
It's
purchased it?
my dad got it.
Oh, okay, that's beautiful. Good.
Sir.
Okay, please get me with the update. Let me get update on you. I started this chapter as others were not in the class. Okay, so last update which you gave me in your PT2, you are having microorganisms, friends, and four, right, Fatima?
Yes, sir.
Okay, which we have completed already in the batch. PT1 is over, no?
Yeah,
You had the chapter one that is crop production in PT1, right?
yes.
Okay, okay. Right now, what's happening in the school?
Sir, right now we are doing the combustion chapter of crop
Combustion
of.
and flame.
Yeah,
Okay. So only two chapters have been completed in the school so far, I'm guessing. And the third
three,
chapter is going on.
three has been completed.
Tell me.
Coal and petroleum.
Oh, okay. Coal and petroleum also has been finished.
Yes.
Mm-hmm. So crop production and management, then microorganisms, and then coal and petroleum has been finished. All right, all right. Okay. And for microorganisms, when is the PT2 exam?
In June, but we didn't get the date. We'll get it during our Hajj holidays. We just have to go to school for 2 days now, and then we have Hajj holidays.
Okay. Summer vacation is going to start.
No, Hajj holidays.
Mm-hmm. Okay, okay. Let's so did you attended any lectures for the chapter Age of Adolescence when we started that chapter?
Which chapter, sir?
Age of Adolescence.
No.
Not yet. Okay. See, currently now actually no one else was there in the class, so I started this chapter Force and Pressure, which is coming in Mustafa's exam. Okay. So what we can do, we can actually continue with the same chapter that is Age of Adolescence, which was going on earlier. But hold on, give me 1 minute. Just give me one. Let me check his exam date. Uh, and when your vacation is starting, Pawan? Sorry, Mustafa.
Sir, summer vacation.
Yeah, summer vacation.
So I don't know the exact date, but like
Hmm.
so like after um, this Thursday, so Friday, Saturday, our Hajj holidays will start.
Okay, you guys have Hajj holidays.
Yes, sir.
Yes,
Oh,
Till like 1 2 week max.
okay, okay.
10 days we'll have Hajj holidays.
Oh, did anyone of you perform Hajj?
No,
No.
sir, not yet.
Okay, Umrah.
Yes, sir, I have.
Yes, sir,
Okay,
many times.
okay, mashallah. That's good. Okay, you guys tell me what would you like to do? Continue with the same chapter, force and pressure, or some other thing?
You can continue, sir.
Okay, so we have just some amount of time left in the class. Okay, in about 40 minutes. So let's cover some of the topic from this chapter. Okay, Mustafa and Fatima. See, so the chapter name is force and pressure, right? So moments ago, I told you guys that I was telling that force is basically a push or pull applied on an object that can change the motion, shape, or the direction of the object. Getting it now? And force is a very fundamental concept. It's a very basic concept in physics that describes about the interaction happening between the objects, because of which they will be changing their motion or either shape, or either they will change the direction in which they are moving. Getting it what I'm trying to say? Right?
Yes.
So whether you push something or whether you're pulling it. So basically it's force. Now, one more thing I told you guys that for force to come into existence, like if I am pulling something or if I am pushing something, so I must be interacting with that object. I must be holding it right now. I must be pulling it with some string, must be pushing it with my hand. So an interaction is taking place between me and that object, right? So that interaction could be contact based. There could be physical contraction, contaction. Physical contact. I mean to say, sorry, physical contact. Getting it now? So we have some type of forces called as contact forces, where there is a direct physical contact. So here we have the example of muscular force. By applying muscular force, we play tug of war, right? Okay. Then we have force taking place over here also. Here also interaction is taking place between the two magnets, right? So when two magnets are placed near each other, either they will attract or repel depending upon the poles which have been placed next to each other. Or here also we have the example of gravitational force, because of which the apple falls towards the earth, isn't it? So this force, for force to come into existence, there must be interaction. Okay, now either that interaction could be contact-based interaction or they could be non-contact, even without being directly connected with each other, even not touching each other physically, the force can come into existence. So thereby we'll be having different type of examples of force. Basically, that will be contact forces, in which you are going to learn about muscular force, frictional force. And then you have non-contact force, where you will learn about gravitational, electrostatic, and magnetic force. Okay. All right. Later on, we are going to learn about the pressure as well. So first, we will going to learn about force. How do we define force? What type of questions related to force may be asked in the exam? How do we measure force? What is the unit of force? Right? What effect does force have on different objects on a given object? Later on, we're going to learn about the pressure. Okay, now. So let us start. Also over here, you can take a look at like on both the direction of this spherical ball. We are pushing it from both the sides, right? We are basically applying force over here. Now, in these examples of frictional force, spring force, of muscular force, there is a physical contact between the object, between the objects, between the bodies, right? That's how this force comes into existence. There's a direct physical contact. Okay, now can you lift this dumbbell without your hand? No, it's not possible. Getting it now? Also, we know that when we are walking or when we are bicycling or something is being moved over a surface, right, over the ground, so thereby we feel resistance while we are moving. We feel like someone is trying to stop the motion of the moving object. Right now, like if you stop pedaling your bicycle, ultimately it comes to stop. If you throw a ball in the ground, that ball eventually comes to rest. Why does it come to rest? Hmm? There is something that is resisting its motion, that is applying a force in the opposite direction. Getting it? So we have frictional force. So these type of contact force we are going to learn about. Then we have got non-contact forces, where the two bodies will be at some distance from each other. They are not in direct physical contact with each other, but despite that, they will be exerting a force of attraction on one another, or either they will repel one another. Okay. So the very first thing, what is force? So when, sorry, when a push or pull is applied to an object, it is called force. It is called as force. And a force can change the state of an object from rest to motion or vice versa. Vice versa, basically opposite, means from motion to rest, right? So whether you push an object or whether you pull an object, right? So that is like you are applying a force on it. Okay. Then force can change the state of an object from rest to motion. Like if a ball is kept at rest, by pushing it with my leg, I will bring it into motion. If a car is moving, by applying the brakes, I will bring it to rest. Right now, getting it both. Okay, these are some simple things. Third important line here is that for force to come into play, there must be interaction between two or more than two objects. Right now, there must be interaction. Like, can the goalkeeper stop the football without touching it? Huh? Is it possible?
No, sir.
Obviously no, right? So he's actually interacting it by holding it with his hand, by stopping it with his hand. So he's trying to push it now, right? He's basically trying to push it. In that manner, he will grab it and stop it. So it can be due to contact-based interaction, where we are directly touching it. Or it could be non-contact based interaction, non-contact type of interaction also. Like if you throw a ball in the air, it will eventually come back to Earth. So Earth is actually applying a force of attraction with which it is coming back to the Earth, isn't it? So interaction is important here. Okay. Now the question is like, if you need to measure force, there must be some unit now. Just like different things have a unit. Speed has a unit. What is the unit of a speed? SI unit.
The meters per second.
Meter per second, right, Fatima? Meter
Yes, sir.
per second, both of good. So just like that, force also will be having a unit. Like just like every other entity has a unit. So it has a unit that is called as Newton. So Newton was obviously named after this guy over here, right now. That is Sir Isaac Newton. Sir Isaac Newton. Okay. Can you guys tell me some interesting fact about? Tell me some interesting fact about Sir Isaac Newton. Mhm. Have you guys must have heard about this guy, right?
Yes, sir.
Must have seen his image somewhere. The guy with the curly hair. Mhm. So what's interesting about this person? What did he do? Mhm.
Sir, he contributed to calculus.
Okay, calculus. Okay, and
And he also discovered the force of gravity.
very good. Right now, so the main work for which he is even remembered today, that is, as you mentioned, calculus, and for his work on gravity, for
Sir, it
discovering
is
gravity.
when an apple fell from a tree. That time he like figured out gravitational force, right?
Yeah, like since childhood, we have been learning about this story. But the story of apple falling on the head of Sir Isaac Newton is somewhat mythical. Okay, no, this kind of mythical. Getting it now. That is the thing. Like it's kind of a dramatic story. I find it a little bit dramatic. Okay, no. Although
Sir,
he observed an apple falling, but it's not that the apple fell on his head. Yeah, Mustafa, you were saying something. Hmm?
sir, the apple it fell like in front of him. Actually, it didn't fall on his head. Like
Yeah,
people
Hmm.
change the story to like that.
Exactly. To make it dramatic, to make it crispy, basically people change the story. Right now, that is the thing. In fact, you guys know, like even today, like you have to be very careful when you are learning history. Like nowadays, what is happening? Huh? There's so much of propaganda almost everywhere that people are nowadays the kids are actually learning history by watching documentaries, by watching web series and such kind of things, right? But there so much of it is kind of like the history is not as interesting. Some of the history is not as interesting as it is shown in the documentaries or in the movies. Getting it now? But what the producers will do, they will add up some spices. Right now, they will basically, in order to make it interesting, they will mold the history. They will twist it. They will add the things that did not actually happen. So one has to be careful. So one should actually learn history or any of the important fact they have to learn from the books. Okay, no? Anyways, so Sir Isaac Newton was particularly known for his work related to gravity and work related to calculus. But one more thing, he also gave laws of motion. Particularly, Newton gave three laws of motion. Okay, now you might have heard about it somewhere. Like to every action, there is equal and opposite reaction. Have you?
Yes, sir.
To every action, there is equal and opposite reaction. So that was actually third law of motion given by Sir Isaac Newton. Okay. So he's known for calculus, as you said. Calculus is basically one of the branch of mathematics. Okay, now Fatima, motion
Okay.
and gravity. Okay, let's get back to this. Okay, by the way, can you guys tell me about this? Like, if you have to compare Einstein and Newton, suppose if you were asked to compare Einstein and Newton, who would you find more deserving of being ranked as the best scientist or the number one scientist of all time?
Einstein.
Einstein, you're saying. Okay, what about you?
Einstein.
Both of them are important because he discovered gravity and he discovered many things. I mean, like, he's the smartest scientist, right?
So I heard that like Newton actually used the works of Galileo, like a ancient
Mhm.
scientist, uh, Greece, I think.
Like both of them are important.
Okay, you guys tell me who came early. Like who came early? Like was it Isaac Newton or Einstein?
Was Isaac?
Isaac Newton.
Isaac Newton, no? Right? Okay. Although saying that who was greater is quite difficult because the contributions have been different and they have been impactful for humanity in their own ways. Like Newton laid the foundation for classical physics, while Einstein revolutionized our understanding of space, time, and gravity. Getting it now? But since Isaac Newton, Isaac Newton was like he came early. And came early, basically mean to say that uh, if I were to talk about what sir this Einstein. So Einstein, like he was in the early 20th century, right now 20th century. He died in the early 20th century, if I'm not wrong, right? Okay,
Yes.
and Sir Isaac Newton lived many years ago now, right now. So at that time, many of the laws were not established. Getting it now? Many of the laws were not established, but during the time of Einstein, so many works in science has been done. Various laws were established. Okay, so he had so many ingredients available to him in order to formulate, in order to publish his works on gravity, motion, and time. But during the time of Sir Isaac Newton, he did not have that much of resources available. He did not have that much of scientific work done. So that much of books were not available to him. So in that manner, if you were to compare, in some way, I find Sir Isaac Newton to be a little greater than Einstein. Getting it? Okay. If you were to understand it from that perspective, like suppose, for example, let's say Fatima, if I were to ask you that you need to do some research work in today's time, you have to do some research work. So if, for you to do some research, let's say I ask you to do research on the leaf right now. So you have so many resources available. You can refer to so many books online or from offline market. You can refer to the books and you can you might eventually come up with some groundbreaking work on leaf. Okay, now you might find something very interesting. But suppose Mustafa, if you were living 200 years ago, right? And at that time, if you were asked to do some research on leaf, so it will be kind of difficult. You may come up with some limited understanding only, right? Because at that time you were not having that much of, you were not having good microscopes, right? Now
Yes, sir.
that is the thing. So it depends upon that also, right? So if someone comes up with groundbreaking work with limited resources, so I think they deserve better praise than those who came up with some research work like at a time period when so much of resources were available. Getting it what I'm trying to say? Anyways, let's get back to the main discussion over here. So force we have learned, it's a push or pull applied to an object. Then we are learning a SI unit of force, that is Newton, right now. So Newton actually gave some laws of motion also. Three laws of motion were given by Newton. So in order to respect him, or in order to make his name memorable, basically the SI unit of force was named after him. That is Newton. Okay, getting it, everyone? And the symbol is capital N, and the symbol is capital N. Okay. Later on, we are going to learn about that in detail. As of now, let us understand some of the important things, like do magnets also exert a push or pull? Yeah. When they are attracting each other, are they pulling each other or are they pushing?
The pulling.
Pulling.
Pulling. When they repel, then
Push.
pushing. Good. Okay. Falling are the different tasks over here. Okay. We need to identify these actions as push or pull or lifting. Okay, na? As push or pull basically. Like you have the description of the situation over here. These are the different actions. In the bracket, you have pushing, pulling, picking, hitting, lifting, lowering, flying, kicking, throwing, shutting, and flicking. So we need to categorize them as follows. So moving a book placed on a table. So what we are doing here, if you have to
Pushing.
move a book, either we can push it, either we can pull it, or either we can lift it also. Basically, we have to move that book placed on the table now, right? That is the thing. Okay. So these actions can be classified as both push and pull. Pushing, pulling, lifting, all of these can be grouped as push or pull. Got it?
So,
Opening or shutting a door. You open it, so thereby what you are
Push.
doing?
Pushing and pulling.
Opening. While you are opening, then you are pulling it no when we open.
Yeah.
And then shutting means
Pushing.
pushing, right? Pushing. Or shutting, this can also be written over as shutting. Okay. So thereby it can be categorized as both push and pull. Getting it? Drawing a bucket of water from a well.
Lifting.
So it can be described as pulling, lifting, pulling and lifting, right? So yes, here it's simply going to be pushing right now because we are not pushing, I mean to say pulling. We are pulling it. A football player taking a penalty.
Sir,
throw.
we can also push it, also lift it
Yeah,
also.
push. You can do both.
Which one?
Pushing,
Pushing and lifting.
lifting.
Pushing and lifting for this one, you're saying?
Yeah, because when he kicks it, like the ball goes into the air also.
See, a football player taking a penalty. Okay, the ball is coming. Suppose I am a football player and I'm okay taking a penalty. Oh, sorry, my bad. I thought like it's the goalkeeper. So thereby it's going to be pushing actually. Okay, and not lifting. It is actually going to be pushing only. Pushing and kicking as well. Right? Pushing and kicking. Pushing, kicking. Right? So that's only push. A cricket ball hit by a batsman.
Sir,
Push.
a push and a lift.
No, not lift. Pushing and hitting.
Hitting also,
Pushing and
lifting also.
flying also can be there, right? Hitting also, right? No, pushing, flying, and hitting. So
Sir,
thereby,
lift also, because like he can like lift it up.
oh yeah, lifting as well. Lifting, right? Now, so in all these actions, it is basically pushing actually only, no, right? Okay. Basically, you can understand it in the following manner. Like when we push something, so we throw that object away from us. But when we are pulling it, so we are bringing it towards us, right? No? Moving a loaded cart.
Pushing.
Exactly. So that is pushing, getting it, pushing only. Opening a drawer.
Lifting.
Lifting.
No, is it
Pulling.
pushing? Pulling, you're pulling.
Okay, that was some simple thing to do. Okay. All right. So the definition, you guys have to memorize it. Okay. Now make sure you memorize the definition. All right. Okay. So we learned about this thing. Now let us understand that what this Newton basically means. Okay. Now, so suppose you have a given object of mass 1 kilogram. Suppose I have a ball that weighs 1 kilogram. Okay. And I need to accelerate it. I need to accelerate it at a speed of 1 meter per second square. Per second square. Getting this thing. Acceleration, you guys understand now?
Yes.
Acceleration, right? So there's a ball of mass 1 kilogram and I need to accelerate it at a speed of 1 meter per second square. So thereby I must be applying some amount of force on it, isn't it? Right?
Yes,
So
sir.
basically, the amount of force required to accelerate a given object of mass 1 kilogram with acceleration of 1 meter per second square, that is called as 1 Newton. Let me repeat, the amount of force required to accelerate a mass of 1 kilogram um, at a acceleration of 1 meter per second square is called as 1 Newton. Getting both of you, please tell me.
Yes, sir.
So,
Okay, now?
sir, you
Mhm.
remember we were talking about COVID in our last class.
Oh, yeah, we were actually talking
Yeah,
about it.
there's 1,000 cases now in
Yeah,
it.
yesterday, like I was reading this, there was somewhere around like 47 new cases of COVID.
Yeah, and everyone who's traveling, they're wearing masks, and in India as well.
Hmm. Right now, where are you, Fatima?
In Riyadh. But my dad, he went to Dubai for some work related things,
Mm-hmm.
so he wore a mask, and he's saying everyone's wearing a mask there for precautions.
Mm-hmm. Okay. See what can be said? Like this disease is not willing to go away. Huh?
Yeah, it
Mm.
went like in last year, but it came back.
Mm. Okay. So basically, this disease actually what happens now if immunity develops at a mass scale, then only a disease can be eradicated. Okay. Like you might have heard about this thing. I might have mentioned that in the earlier times, like in the Europe, millions of people died because of bubonic plague, because of the Black Death. Okay, no, there was a plague that was caused by the rats. Okay, that is called as Black Death or bubonic plague. So millions of people died at that time. Getting it? So people throughout the history have been dying because of different reasons. Also, you know that uh, after the Battle of Plassey, have you guys heard about Battle of Plassey, 1757
Yes, sir.
in history?
Yes, sir.
Okay, okay. Let me basically what I'm trying to say that in the 1750s or 1759, at that time about one third population of the Bengal died of famine. There have been famine in Bengal multiple times, and vast number of people have died because of famine. Okay, so throughout the history, we get to see that people have died because of famine, because of epidemics or pandemics at mass level. But nowadays,
So
So
medical
what?
facility has
in
So
the
what?
improved.
18, in the 1800s, there was one more virus, right? The Spanish virus. Have you heard of it?
Spanish virus.
Yeah,
Yeah, Spanish virus. So many people have been infected because of this. Somewhere on like millions, like hundreds to millions of people have been infected because of this.
I
Okay.
really hope the virus goes away because a lot of people died in 2020 because of it.
Hmm. Yeah. In fact, also from my college, also several professors died because of COVID. Okay. There were some professors that were really very close to me, and like their death really shook me. Okay. So like I could not digest the news for like 10 days. So yeah, in COVID, so many people have died. What could be done? Okay. The government have failed us getting it. There are not enough hospital beds available. There were not enough oxygen cylinders available to the people getting it. Particularly here in India, like you know what the condition is like here in India, right?
Yeah.
How the government works, how people are fooled. Hmm. But still, people needs to be enlightened. People needs to become literate. People would be choosing the same leader again and again, even if they don't work for them. So the situation is quite complex. Getting it? And that's why many of the Indians, like so many Indians, leave their citizenship every year. You will see that it would be surprised like lakhs of Indians leave their citizenship every year. They would be abandoning their citizenship. They don't want to live here anymore.
They either US or Saudi, Canada.
They'd be moving. They would be moving to other countries for better life, for better employment. Getting it for the same skill, they would be if they are getting paid better in some other country. So why won't they go? Yeah. So that is the. In fact, the healthcare system is not good here, right? The infrastructure is not proper. The drainage system is not proper, right? Like in London, there was a time in London when the situation was so bad that people used to do manual scavenging, and at that time the septic tanks were not well developed. So the human fecal matter, the human waste, there was some workmen, with some people who would come to the house. They will collect the human fecal matter, and then they will dump it in an area. They will carry it away, and they will dump it. And they used to charge so much for that piece of work. Getting it? So eventually people got frustrated. They went on a strike. They demanded the government to do something regarding this issue. And then in London, a very well developed drainage system was made, and it is effective even today. But here in India, even in cities like in Delhi, in Mumbai, in the metropolitan cities, you will find the drainage system is not proper. So what can be said? Getting it? Anyways, let's get back to this topic. Okay, no? So we're saying that if an object has to be moved as an acceleration of 1 meter per second square, and that object weighs about 1 kilogram. So the amount of force you need to apply, that is called as 1 Newton. Getting it, both of you?
Yes.
That is the thing. So 1 Newton equals to 1 kilogram per meter. Hold on. Force equals to, later in the class we'll learn in the ninth grade particle that force equals to mass into acceleration. Mass into acceleration. Suppose if the force is 1 Newton, so that will be equal to 1 kilogram multiplied by meter per second square. So that is simply 1 kilogram meter per second square. Getting it? 1 kilogram meter per second square. In higher classes, you will be learning about that particularly.
Sir, the periodic table we learned it in 10th, right?
Periodic table.
Yeah.
Periodic table you guys would be learning in the ninth grade actually, I think. Okay. From hydrogen till calcium, it would be better if you memorize till calcium. Okay, no?
I have
Along,
to memorized.
you should basically you can get it a printout of the periodic table and you can paste it in your study
Sir,
room.
there's a really famous song to memorize it as well.
Yeah, but don't go after such things.
Yeah.
Okay, no? In order to memorize it, you have to memorize the song, and then you have to memorize that names of elements. All why do multitasking? Simply memorize the name. Okay, no? Never use such kind of shortcuts.
A lot of people have it, like a printout of it, and they keep it with them.
Yeah, so memorize them in a sequence also. Make sure you memorize it in this, like hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, like this. Okay, in a sequence. Now talking about the characteristics of the force. So force has got magnitude and a direction. Magnitude here, in simple terms, means it has strength. It has some value, right now, right? So force will obviously have some magnitude, no matter how big or how small it is, no matter whether we feel the effect or not, but it will have some value, right? And obviously there will be a direction in which that force is being applied. So these boys are applying some amount of force on this object. Together, let us say that they are pushing it with a force of 100 Newton, and they are pushing it in a direction also. No? So it has some magnitude and a direction in which it is being applied. Then force can make an object start moving from rest, right? Now, suppose this object can move, right? Or suppose if it was already in motion, let us suppose. So thereby, by further application of the force, its speed may increase, right, Mustafa? Right, Fatima? Getting it? Or suppose by application of force, we can deform the shape or the size of the given object. What we can do, like if we have this given object over here, like a rubber band, we can stretch it, we can press a sponge or squeeze a spring. So thereby their shape and size can be changed by application of force, isn't it? Got it, no? Then force is measured in Newton. The SI unit of force is Newton. And that's the international system of unit, which you already know. And force will act on an object. Obviously, force must act on an object to have an effect. No? Getting it without an object, force has no impact. Right? Can there be force without talking about an object?
No, sir.
That's not possible. Okay. Further, it may act through contact or at a distance, right? Which you already have learned a little bit that there are contact force, which requires a physical contact, or you have non-contact force, which will be acting from a distance even without direct contact, like gravitational force, magnetic force, and electrostatic force. Next, we have a very important concept to learn that it can be balanced as well as unbalanced forces, which we'll be learning in detail. Okay. And one more thing I would like to tell you that force always acts in pairs, in pair. Like here, as the boys are pushing it with some force, with a force of 100 Newton. And let's say this is a piece of wooden block, right? Wooden cardboard. So it is placed over the ground. They are moving it over the ground, right? They're not moving it in the air, obviously. In the ground, they're moving it. So the ground must offer some friction, no? Isn't it? Suppose that's the ground over which we are trying to move it. So the ground will try to apply the ground will apply a frictional force, and that frictional force is in the opposite direction now, right? So force is being applied in this direction, as you can see here, and you can see how frictional force is being applied in the opposite direction. So frictional force basically opposes the motion of an object, right? So force here is acting in a pair now. Pair, you understand, right? Getting it? So force always acts in pair, meaning that if I am pushing something, so there is actually a force from the opposite side also. As I am pushing this, right? So the object is not actually pushing me. Uh, Object is also not applying a force of push on me, but actually since it is placed on the ground, so thereby there is a frictional force between the object and the ground, and that is acting opposite to the direction in which I am trying to push it. So there is a pair of the force now, this force and this force. Understood both of you now? It is very important. Okay, let me give another example also. Suppose you have given a slight push to this ball, or suppose you have a toy. Suppose you have a toy and you have given it a slight push, right? So you have applied a force here. Now, as it is moving forward, will the ground not apply some force on it? Will there be no friction force?
So the ground will
Yes, sir, there will be.
Right? So there is force from this direction
might
also.
not always go in the right direction because
Mm.
of the force.
Yeah, it will be opposing the movement of the body. So there is a pair of force now, pair of the force, right? Or let us suppose that when you play tug of war, right, you are holding a rope, right? You're holding a rope in your hand. The other team is also holding a rope. So you are trying to push it in this pull it in this direction. The other team is trying to pull it in this direction. So there is a pair of force in this also, isn't it? The word pair is should be clear to everyone, no? Right? Pair, right? Two or multiples of two, right? When there are things in groups of two, it is called as pair. So force always acts in pair. Please tell me if that is clear.
Yes.
Yes, sir.
Okay. These things which I already told you that
Continuing with this chapter in the next class.
this chapter. No, actually, we might not be continuing this chapter. Okay, now we will follow the sequence, Actually, this thing got a little bit disturbed. Why so? Because like some of you join after 5 minutes, some of you be joining 10 minutes after 10 minutes, some of you be joining after 15 minutes. So thereby it kind of creates a bit of difficulty sometimes. Okay, no? Today Pawan is absent. Sana will be joining after some time, like after 1 or 2 weeks, I think. So the things quite become complex in the batch. Anyways, so force always has a direction in which it is applied. Can force be directionless? Think about it. Can it be directionless? It's not possible, no? Right? A force can be applied, like when a force is applied on an object, it'll always have a direction. Either it is applied on the left side, right side, up, down, right? Diagonally. So force always has a direction in which it is applied. Okay. Plus it will have magnitude. Then the effect of force may alter when the direction of the magnitude of the force is changed. What it means to say, like suppose that if there's an object, okay, now I am pushing it with a force of 50 Newton. All right. Now, when I push it with a force of 150 Newton, so the object will have different effect now, right? The
Yes.
effect of force will get changed, will get altered when the magnitude of the force is being changed here, or when the direction is being changed here. Instead of off, it means it should be or. So when the direction or the magnitude of the force is changed, so thereby the effect of force may also change. Earlier, I was pushing it with a force of 50 Newton. Let's say this object was moving with a speed of 10 meter per second. But now since I have increased the magnitude, let us suppose now it becomes 30 meter per second. Getting it, both of you? So its speed increases as you change the force. I have increased the force now. Now let us suppose I have started, let's say earlier it was moving in the right direction, right side. But now, Fatima, what I'm doing now, I'm applying the force on it from the other side. So it will be moving in this direction now towards the left. So when we change the magnitude and the direction of the force, so the effect on the object is also going to change. Tell me if it is clear.
Yes, sir.
Okay. So
Yes,
today
sir.
we have learned several interesting things from this chapter. All right. In the later classes, like when this chapter will be resumed, then we'll be